Hello, this is Unit 1 of the Arduino section of the CSC270 course at Smith College. Um, so I have my notes here on an iPad, and I'm going to flip through them and annotate them as I'm going along, and we'll make the PDF of the annotated version available as well as the original one. So you can pick whichever one you want to use. So introduction to the Arduino. We're looking at it as computer scientists, so we're going to go a little deeper than what the regular hobbyist may want to do. So I will briefly go through an introduction, talk about how it's organized, physical layout, the specifications, see what's actually on it. Talk about power, because that's important, how we're going to power the Arduino, and talk about the memory, compare that to what we know, and then how we program it. So briefly, I'll go over digital I/O and really not quite over analog I/O. All right, so history, a little bit of history. When was it built? It was built actually in 2003, and it was part of a master's thesis. And what is interesting is that the two supervisors, so the name of the person is Hernando Barangan, and the supervisors for this master's thesis were Massimo Benzi and somebody you may have heard the name of before, Casey Reyes. And Casey was instrumental in another project that has been very popular as well, which is a processing language, which is a programming language for artists. It's basically Java without the heavy part of Java, without all these libraries for data structures and so on. And it's a Java that is made simpler by simply having two functions for doing any kind of drawing or animation. You have the setup function that is executed first, and then you have a draw function that is executed repeatedly. And by having this repeated draw function, you can put animation and be able to follow the mouse as it moves around the display and do all kinds of interesting things. So if you've done processing before, you will see that the IDE for the Arduino looks very similar. And here it is. So here on the left, what you have here is the Arduino IDE, and on the right you have the processing IDE. And they look very similar, and not only do they look similar in the way they've organized, see there's a little button here for starting, little button here for starting, and something going on here, something going on here. And then if you look at a sketch. So for the Arduino, we're going to talk about a sketch, not a program, but a sketch where you put your instructions. And for processing, it's the same thing. You have a sketch, and you have a setup function and a draw function. For the Arduino, we don't have a draw function. It's called a loop function, but we have these two important elements. So on the board itself, the board is called the Mega 2650. It's made by Elegoo, which is a Chinese company, started in 2015. Although a year ago when I looked at this reference, it said started in 2011. So 2015 may have been when they changed maybe the CEO, or maybe got new funding and some important element of the company may have changed. But anyway, it's a fairly recent company, and they're located in Shenzhen, which apparently is the Silicon Valley equivalent of the United States. And it's a fairly small company, 100+ employees. But so that's where the kits come from. The whole kits have been made by Elegoo for the Arduino, for that board that they're making. And it, by the way, it's compatible with the Arduino that is made in other places. I have three good references. So one of them you know already, that's our webpage for CSC270. At the end of the schedule, I will put some references to different things that could be interesting to you. The Arduino itself webpage is great. They have many sketches, examples, tutorials, so it's a great page. And if you're a Smith student and you're on the VPN to Smith, you can access Linda, which is free, which also has some good information. If you have questions about programming, you'll see today we'll look at 3 or 4 different functions. There's a great programming reference. It is on the Arduino CC website. And today we'll see digital read, pin mode. Everything that we look at is well defined, and you can find all this information here. So this is a very good reference. I recommend it. There's a great intro movie on the web for this. So the link that is here should be clickable. So if you have this PDF, should be able to click on that and go there. If not, just go there, stop this video, go there, and follow. It's 4 minutes. It's a nice little intro. So, all right, assuming that you're coming back, what you will have learned is that there are plenty of different pins around, and the ones that are of interest to us in the beginning is they're the digital pins. So right in the middle here, it's hard to see. Let me use a different color. Right in the middle, that's a processor. So this guy here is a processor. And you see that there's very little around. It's basically a series of wires, and we see all these little connectors here. And we have a crystal here, 16 megahertz. The USB port, that's how we're going to connect to the Arduino and power it and program it. And then if you want an Arduino that is by itself, not connected to a computer, then you'll put a charger connected to that. And you should all have a charger in your kit with the Arduino. So that's the important part of this board. So you see there's not much electronics except the center part, which is really a system on a chip, SoC. System on a chip is the processor, the memory, and a lot of ports around, and which is that's what the little box is. The pinout will have to learn how to read different diagrams that show us where the different pins are. They're all numbered. And so again, in the beginning, what we're going to be using are the pins that are right here, the digital pins. So the processor on that board is the Atmega 2560. It's an 8-bit microcontroller. So we don't say microprocessor because it has more than a processor. It has memory and ports. So it's a microcontroller. It's a RISC architecture. It means reduce instruction set computer. And basically what you need to know from this is that it executes one instruction in one cycle. That's basically what RISC means for us, that it's an architecture where the instructions are so simple that one cycle is sufficient to execute each one. So 16 megahertz basically means 16 million instructions executed per second. These are the instructions that we talked about in assembly language. When a program in assembly language is made of instructions, and each one is translated into an opcode, one instruction per second. It's an 8-bit microcontroller, so that means that it can only move pretty much 8 bits at a time, so it's not much. Our laptops have processors, Pentiums, that operate that are 64-bit processors, so they can play with bigger chunks. So integers are going to be bigger, and floats, and so on. So the Atmega 2560 is not a processor made for doing math, and we'll see that next unit. There's 64 digital pins, which is great. So think about, you could have 54 different LEDs blinking in different ways. Anyway, 16 analog pins. So analog means something that is not just 0 or 5 volt, but can be anything in between. So we'll see that we can read signals that vary between 0 and 5. Or we could also generate signals that are not 0 or 5, but average out to be a voltage in between. And that's great if we want an LED that slowly turns on and slowly turns off. We'll be able to do that. 16 megahertz, we just talked about that. Program with a custom IDE. So that's the IDE right here. If I switch to this view, this is the integrated development environment with a setup and loop right here. So that's the IDE. And serial communication ports, it can communicate serially. We see that with a USB. So when you write USB, where am I? Here. USB, the S in USB means serial. So that's how communication takes place between the laptop and the Arduino. So it also has ports, serial ports we can use to communicate with other devices besides a laptop. So operating voltage is 5 volts, which is exactly what is delivered by a USB cable. But we can also use a 9-volt battery. This is too bright. I'll use 9-volt battery. And we'll see that there's an input, particular input, where we can provide any voltage between 7 and 12, and it will extract 5 volts from that. And that's how it's going to work. Flash memory is 256 kilobyte. I'm putting this there so that you can compare that to the 8 gigabytes or more that you have in your laptop. So a gigabyte is 1,000 megabyte. A megabyte is 1,000 kilobyte. So this, the flash memory here is 256 kilobytes. So it's about 4,000 times less than what you would have in your laptop. The RAM, there's a RAM that is 8 kilobytes. So what's the difference between flash memory and RAM, random access memory? The RAM, as soon as you power off your circuit, whatever is in the RAM disappears. Flash memory, whatever you have there will remain until next time. And EEPROM is where the BIOS, the basic input-output, the operating system, if you want, is going to be stored. All right, so power, we have 4 options. We can provide power 2 different ways. So that's why these arrows go to the left. So we provide power through USB, or there's a pin called VIN on the Arduino, and we could, if we wanted, provide 5 volt there. That's an option. And the board can also can give 5 volts to devices that we may have on here, maybe. If I were to put some circuits on a breadboard, and I could power the breadboard using the Arduino. So it has a 5 volt pin and ground that I could use from the Arduino to power that. And then finally, there's a 3.3 volt output. There's some electronics that work of 3.3 volts. We haven't seen that in our course, but there are some chips that are different, operate at lower voltage. We could do that if we wanted. Not going to be important for us. All right, so that's the actually that's the original Arduino, which is slightly different. That's the original Arduino, and that's the one we're using. So the diagram that we have here shows where the different power pins are, and they're very similar. They're on a different. So these 2 boards that I showed you are similar, pin to pin in some ways compatible. So the VIN 3 volts, so we see where everything here is. And if we have a battery, we can connect it there. All right, how long can a 9 volt power battery last if you connect it to an Arduino? Well, it's not very easy to figure it out. It's all going to depend on what is connected, what kind of hardware you have attached to your Arduino. So one solution is to use one of the input pins, an analog pin, and to measure the 9 volt voltage, probably using a voltage divider and 2 resistors. And what we do is we see, when that 9 volt comes to be too low, then we could have the Arduino turn on a red LED to indicate low power, something like that. So we don't really know the answer, but we can make the Arduino tell us, which is great. Memory. Okay, so I've mentioned that 256 kilobytes of flash, so very little. So basically the idea here is that there's very little memory, and it can be used for different things. 256 kilobytes is for the sketch typically. 8 kilobyte of RAM are for variables, that like if you have a counter that the Arduino is maintaining, that's going to be there, which means that when you power down the Arduino, your sketch, which is going to be in flash, is going to remain and be there for the next time you power your Arduino on. But all your counters, all your variables will have been cleared. And EEPROM, very small, that's typically where you store long-term information. So at some point, if you want to do serious stuff and you get you kind of hit the limits of the Arduino. Then there are ways of moving information into EEPROM or different memories. By default, we don't have to worry about it. We don't have to do anything. But if at some point you're trying to figure out, hey, I'd like to keep some data when the Arduino is powered off so that I can get this data back when it's powered back on, then there are ways to do that. And you have to move, you have to, program your variables and move them in particular places. And there are libraries for doing that, so it's available. So that's what I have right here. All right, so programming the Mega 2650. So I'm going to do that. So my Mega is connected, so the other end of this cable is connected to my laptop. And this guy is connected here. And this little LED tells me whether it's turned on. And what I'm going to do is that I'm going to find the blink. So the hello world of the Arduino is called blink, and it makes the LED onboard blink. And I'm going to show you here how I can load it. So I'm going to go to File. So I'm connected to my app here. File, Examples, Basics, Blink. Okay, so that's the blink sketch. I'm going to make it bigger here so that we can see it nicely. And it has a long header. I'm going to remove it. You can read it separately on your own, but I'm going to remove it to make it simpler. And here I have my setup function right here. And I have my loop function right here. So what does the setup function do? It says pin mode LED built-in output. So it's gonna, so there's a pin, so there are constants that define all the different pins, and the one pin that is connected to the onboard LED is called LED built-in, and I'm going to make it an output. I'm going to make that pin receive a high or low voltage, and so the setup, I have to indicate whether my pin called LED built-in is going to be an input or an output. We always do that in the setup, so that's this constant output. And then in the loop, what I'm going to do is that I'm going to write high and low alternatively to this pin, to LED built-in. So I'm going to turn it on, turn it off, turn it on, turn it off. And I just need to do it only twice, on and off, because the loop function here is going to be called forever. Okay. So actually, let's go back here to the slides, and what we see here is that this is the sketch. Setup. Oh, let's undo that. Let's go back to that. Setup. Hello. And then loop. And so the way it's going to work is that setup is going to be executed once. So what you see at the bottom here is a time axis. So setup is executed once, and then the loop function is going to be executed repeatedly. So there's an endless loop that is not shown here that will call my loop function forever, once after the other, with no delay. Maybe a tiny bit. So see here, I've put a little bit of a white space. So there may be a millisecond or so, even less, between the calls, because something else has to take over and call loop again. But loop is going to be called over and over and over and over. So what will it do every time? Well, it will do one period of that blinking pattern that we have. So high for, so the signal is going to be high, and then for 1,000 milliseconds, so that means 1 second, it's going to stay high. Then we're going to turn it low, and then we're going to wait 1,000 milliseconds, 1 second again, and then loop is going to start over again, and it's going to turn the LED on, wait 1 second, off, 1 second, on, 1 second, off, and that's how that's going to work. Okay, so that's the typical behavior. Typical behavior is during setup, you initialize the pins. You say, I'm going to use these pins, and some of them are going to be output, some of them are going to be input. And then you do that once, and that's sufficient. And then loop takes over, repeatedly. And what loop does, it checks the sensors, it checks whether some things are turned on, some switches, some voltage, and then will activate LEDs or activate motors or all kinds of different things. But it does it in a loop all the time. So there's typically only two different ways of programming sketches. The first one is what you do is you have only one thing that you want to happen and you don't care to repeat or keep on monitoring things. So in this case, you put all your code in setup, and that's it. It's going to be done once. You're going to see, we're going to do the 8 queens. We're going to solve the 8 queens problem in the next unit, and I'll put everything in setup, and I won't need a loop. So that would be the first way of using a sketch. The second way is when you're doing monitoring and turning on things on and off. So you do the setup first, you set up your pins as input or output, and then in the loop, you monitor and you turn on or off different things. So that's the second option. All right, so here I'm showing you a different way of operating, or different sketch, where I have a variable called count. So that means that very likely, I'm not showing it here, but I had to declare count as an int and initialize it very likely to 0 somewhere. It has to be done outside the loop or the setup function. It has to be a global, so I do it not inside a function, kind of a global variable. And so what I'm doing here is that I'm incrementing count. And I'm not shown here either is a function called func somewhere in the code that will do something with count and then will return a value that I'm going to store in X. So that's what that line does. And then I'm going to wait 1 second. So I have computation, delay. And so what you see here is that computation, delay, computation, delay, computation. That's the way the sketch is going to operate. And so the computation will always be the first thing that we do when the loop starts, the loop function starts. We delay for 1 second, and then the pattern repeats. Okay, important note, when the Arduino is powered back, it will automatically restart the last sketch that was uploaded. So it will start. So not only will the Arduino be powered up, but it will look in its memory for the sketch, the last one that was loaded, and it will start over. So setup is going to be executed once automatically, and then the loop function will be called repeatedly. All right, the last concept that I want to cover in this unit so that you have enough to kind of play is printing. Printing is good for debugging, to report on the screen about what's going on with your Arduino. So the Arduino doesn't have a display, doesn't have a keyboard or anything. So in order to print things, what we're going to do, so I'm going to go back to my Arduino IDE, serial begin 9600. So remember the S in USB means serial. So serial begin means that this Arduino, when it receives this sketch, will communicate over the USB using a serial protocol, and the number of bits per second will be 9600. So it will use, which is the slowest. So that's the safest one to use. 9600 bits per second will be used to communicate with the laptop. So I'll have to tell the laptop that we are communicating at 9600 baud. By the way, yeah, the unit is baud, B-A-U-D. Should write this down. That's the unit. We don't say bits per second because they're not. The bits that are used are both control bits and data bits. So if there were only data bits, we would say 9600 bits per second. But because we also have a start bit and stop bits to indicate the beginning and end of a byte, we said baud. So that's the unit that's been used. And here, so serial is a library that we don't have to load. It's going to be there automatically. Print line. Hello, CSC270. Okay, and then delay 1 second. All right, so that's the sketch that I'm going to load. I can verify it to make sure. Oh, I have to save it first, so let me save it to my desktop hello world. So it will be stored on my desktop in a folder, and inside the folder will be this a text file which will contain just that. So I passed, so the sketch we see at the bottom of the window here, the sketch didn't generate any errors, so I can download it. All right, so I'm going to open the serial monitor. And the first thing that I want to do is that I want to go here at the bottom of the screen, and I want to make sure that the baud rate is 9600, which it is, and this number has to match that number. That's it. Clear the output. Right now I don't have anything, so that's all right. So I'm going to go back here and I'm going to download. So little arrow will download the sketch in the Arduino right here. I'm going to put it right there, so you're going to see that something should happen around here, some blinking, and that's the blinking you'll see will be the code, all the bytes from the opcode from the program that has been generated here, that's been compiled, will come in, and the Arduino will respond saying, okay, I got it. So there will be two LEDs. Good, that's it. It has just happened. I'm going to do it again, download it. See this? So that's a sign that the sketch has been compiled first on your laptop, and then the executable has been downloaded in here, and it's now, we see it, it's printing hello CSC270 at 1 second interval. So that's that. And so the blink, let me go back to blink, open recent blink. Okay, so that's the blink. I can download this now. It has cleared this window, and I should see my little, let's see, where is it? Right here, my little LED blinking here at 1 second, which is the sketch. And okay, so where is it? Right here, there's a little button, that's a reset button. When I reset it, I force the Arduino to go back to setup and then run loop many times. If I disconnect my Arduino, so it's powered off, that's the best way we know of powering it off. If you connect it back in, we should see the LED start blinking again. Okay, because the sketch is still in there, and that's the sketch. The last sketch that we had was the one that was blinking, so that's what we see happening. All right, so serial print challenge, explain this. So look at this at your leisure and figure out if the display that you have here makes sense given the sketch that I'm using. So I'll let you do that on your own. And answer these questions. Try to answer these different questions on this. And then blink, so I would say try to load blink. See if you can make it blink. And so when you download the IDE, you should have all the sketches. All these examples should be part of your environment, so you'll have access to plenty of sketches already written. All right, that's the end of the unit. So what I recommend is that you review all the slides, and then you play with blink, and maybe with the print, just so that you're familiar with just that part. And if you can do that, that means that we're ready for the next part. So the next unit will look at more advanced features, but in particular, I want to see how fast is our Arduino. I mean, is it something we can put some computation on when when you have too much going on the laptop? So we'll take a look at that. So see you soon for Unit 2.